Inviting me to speak. What I want to speak with you about today is really the story of how TerraCycle began, where we are today. We're actually very excited that we are now operating down here in Israel for the past 6 months. And I want to talk to you about the whole idea of garbage and how that changed in our minds and what we're trying to do to really reinvent the whole world of garbage. Now, before I get into what TerraCycle does, I want to tell you the story of how we began. 9 years ago, I was a freshman at Princeton in New Jersey, and my friends and I in Montreal, I'm originally from Canada, were growing these very special plants in our basement. You can see my friend trying to grow these plants. Now they're very difficult to grow, and he had a really lots of trouble. He started feeding them though worm poop, and worm poop is organic waste fed to worms, and then the worms create excrement or poop, and it becomes a fantastic fertilizer. And my first break, middle of my first year of university, I went up to see him, and the plants were looking much nicer. We were very excited, very inspired, and basically decided that, you know, this is a great business to try to think about how we could take garbage and make it into a fantastic fertilizer. So I went back to Princeton and said, look, we're going to figure out how do we take tremendous amounts of organic garbage, things like green garbage, and turn them into fertilizer. So I went back and convinced the university to give us phenomenal amounts of this, which is organic garbage. It's not too pleasant. And we invented a system that could convert this garbage into a huge amount of fertilizer. The way the system worked was quite simple. This is the system that we created. This is set up at the university. In the back corner, sort of at the most left-hand side of this picture, you can see how it began. We took organic waste, we put it into a machine which rotated, and it was an advanced composter. We basically added air, we rotated, and within 24 hours, the organic material would be starting to get very, very warm. Then, this was the special part, we put it into this big system, which is our worm system. And it relies on one very simple philosophy, and that is that there's no animal, unless there's an exception maybe in the audience, that likes hanging out in their own poop. It's very rare. I don't like to do it. And if you think about it, you know, a toilet, for example, is a machine that we have invented that takes our excrement away from us as fast as humanly possible. You know, you sit, you do your business, and then you press a button, and it's already in another city in maybe a minute or two. It's just gone. Same idea here. We put the waste down the middle, or the cooked waste, and the conveyor belts, as you can see in the picture, went in an outward direction, while the worms went away from their poop in an inward direction towards the middle, because they like to go away from their excrement into the new food. So what we did is we timed the conveyor belt to go down at the same rate the worms went up, which is about 1 inch every 5 hours. Very, very slow, but at the edge what would fall off was a fantastic fertilizer. So this is how the business began. I ended up dropping out of Princeton about 1 year later to dedicate all of my time to creating worm poop. And we started building up a big inventory, but the really big problem was that nobody would invest in this business. We were trying to get all this money and absolutely nobody. My dormitory was filling with worm poop, and my roommates were not too excited. And we decided, because we couldn't raise money, we need to start selling our product. Now the very big problem that we ran into, and we had figured out how to turn it into a liquid, more like a fertilizer tea or a liquid fertilizer, is how do we package our fertilizer? We want it to be extremely environmentally friendly, but we had no money. We couldn't afford bottles. And the biggest challenge we ran into is that the more environmentally friendly the packaging became, the more expensive it became. So the cheapest package in the world is a bottle made from no recycled plastic. Say, just as an example, this would be the cheapest way to package a liquid. If I want to make it better, maybe more recycled PET in this bottle, then the price will go up. If I want to make this biodegradable, made from PLA, the price will go even more up. So the more eco-friendly I want it to be, the more money the consumers would have to pay. And the big issue is that consumers are not willing to pay even a penny more for something that's green. That's the most typical response. Now, since we couldn't afford bottles anyway, this whole problem wasn't really even all that relevant. And we decided to try to package in garbage. The first product we ever launched was this one. What's really special about this product is every single aspect of this product is garbage except the label. That's the only part that's new. We had to use a shrink label because every bottle was different. One was a Coke bottle, one a Pepsi bottle, one and so on and so forth. Even the little spray top are leftovers from big companies, pre-consumer waste, where if a company says, well, yeah, last year yellow was a very good color, but this year pink is the color, then 250,000, 500,000, 2 million of the yellow ones are thrown into the garbage. So what was really interesting when we created this product is we were very quickly, the lawyers from both Pepsi and Coke called us and said, well, we like what you're doing, but it's illegal to use our trademark shape with something else. And they're right, it is illegal to do that. So what we had to end up doing to get this product out there was get a license from both Coca-Cola and Pepsi to package literally shit in their bottle and sell it. I think we're the only, actually I'm certain we're the only company in the world who has this license. Now, this is how this whole thing began. At this point in time, we were very excited. We had a very cool product. It worked very, very well. And because it was made from garbage, it was cheaper than any other fertilizer on the shelf. So we thought, and you'll see as I give you this presentation, that we always try to think as big as absolutely possible. We said, well, look, what's the biggest retailer in the world? Walmart. Why not try to sell it first there? So we made a lot of phone calls. We went down to Arkansas and presented. And keep in mind, it was just my friend and I, and we were still in university. We didn't have factories. We sort of pretended we did. And we went in, and the buyer for fertilizer, was very excited and said, great, 100,000 bottles in 4 weeks. I said, okay, sounds good. So we went back to Princeton, and I got all my friends to volunteer. We went through all the recycling containers. There was one group of people who was collecting the bottles, another group with a knife who was cutting off the labels, another group with just a little funnel putting the liquid in, and then one other group. The way we put the labels on is you take 4 hair dryers and you put them in an angle, and you dip the bottle and put it up. The weirdest thing was when trucks and trucks were coming to the university to pick up this product. We ended up making the delivery on time, and once that happened, we ended up getting a factory, and as soon as Walmart was satisfied, every other major retailer in America very quickly joined. That was in year 1. 4 years later, we were about a $4 million business, making worm poop fertilizer, selling in every major retailer in the US. Now, one very, very interesting thing happened is the way we started getting bottles is we created a program called the Bottle Brigade. The way this program worked is that you could go to our website, sign up, take a box, fill it up with bottles, send it to us. We paid the shipping, and we gave a donation for every bottle that was delivered, sort of as a privatized bottle bill program. And we were getting millions of bottles in the coming into us. It was very expensive for us to run this, to be able to function like this. The Bottle Brigade was costing us almost $1 million every year to run, while we were still a relatively small business, around 4 million or so in sales. And we started going to companies. The first 3 companies I went to, one is a brand in the US called Stonyfield Yogurt. It's a yogurt company owned by Dannon. Another one is an energy bar called Cliff Bar. And a third one is an organic iced tea company called Honest Tea. I wanted to go to these companies because I knew their CEOs, because we were in the green industry. And I went to them and said, hey, would you be interested in sponsoring our bottle collection program, because we need help and we want to collect as many bottles as possible. All 3 of these people said, well, that sounds really interesting, but we all have problems. As you heard from the presentation before, yogurt cups are not recyclable. So Dannon said, well, why don't you help us with yogurt cups? Then Honest Tea said, well, why don't you help us with juice pouches, because they're not recyclable. And Cliff Bar said, why don't you help us with energy bar wrappers, because they're not recyclable. And that started the real journey of what TerraCycle is all about. The fundamental question that we have always asked ourselves is, what really is garbage? This is the most important question to ask first, because if you answer this, then everything becomes very simple. The first and most important thing to look at is garbage doesn't exist in nature. It's a non-natural idea. There's no such thing as garbage in the natural system. The output of one ecosystem is the input for the next ecosystem, and there's not a single example of garbage in nature. Nature wouldn't even have the word garbage, it just doesn't exist. So, naturally, garbage is a modern human idea. It's a man-made idea. And I think it's also a very new idea in the sense that it's probably only 50, 60 years old in the sense of what it is today. Today we have two big problems that create garbage. One is consumption. As the speaker before was saying, we buy way too much, way more than we need. Think about it, like if we go back 60, 70 years, if my sweater today rips and I get a hole, I throw it out, I buy a new one. 50, 60 years ago, if my sweater rips, I go to somebody, they sew it, they fix it, I wear it again and wear it and wear it, and then maybe give it to somebody who wears it, and so on. That's one issue, is consumption. The other is complex materials. Things like styrofoam, plastics, all these different things that nature cannot deal with. So when you add consumption and complex materials, you get garbage. Now, I was taking economics at Princeton, and all day in economics, all we were drawing was these supply and demand curves. That's all we ever did, was draw lines and see how they move. And the only material that intersects in the negative, which means it has negative value, is garbage. And that's the definition, in a way, of garbage. Something that we are willing to pay to get rid of. If we're not willing to pay to get rid of it, it's just a material with value. It's not garbage at all. Now, obviously, garbage is a very big problem. Globally, 5 billion tons a year of garbage are produced. And if you look at there's all these stories of every gyre in the oceans are filled with garbage. It's not just one big garbage patch. There's like 3 or 4 all around the world. Now, there are two types of garbage. There are recyclable garbage. Again, something like this, you can put in the recycling and this will be melted and something new will be created, which is fantastic. But then there's non-recyclable garbage. Your pen, your toothbrush, a dirty diaper, a cigarette. All these things you can only put in the garbage and there's no other solution. The issue is when you look at all products, not packaging, but all products, everything we touch, this microphone, this computer, this whatever this is, and so on, all of it, 80% of that is not recyclable in our current system. So what happens with 80%? One of two things. Depending on what country you're in, and this is typically correlated not to how advanced the system is, which is a misconception, is correlated to how much land is available in the country. In America, where there's a lot of land, or Canada, most of it goes to a landfill, and it's basically a big pile, and a little bit is burned for energy. In Europe, for example, where there's very little land, most of it is burned for energy, and a little bit of it goes to a landfill. Now, let's again look at garbage. The important thing when you look at garbage, I just will keep using this as an example, is that it's two things. This bottle, forget that once I drink all the water, it's just a bottle. Now there's two things that the bottle is. One is its plastic, and that's what is valuable. The other is the shape of the bottle. It costs a lot of money to turn that plastic into this shape. So all packaging or all garbage is really two things, content and form. So what are the solutions today to this bottle? Well, the worst thing to do is to send it to a landfill. I think we can all agree that that's the absolute worst thing to do, and there's no value that's created at all, no positive value. Now, you can burn it for energy, and what you do there is you generate the caloric value, the energy potential in the bottle. The challenge with waste to energy is the things that are recyclable, like this bottle, have the most energy in it. The things that are non-recyclable have the least amount of energy in them, especially things that are wet have even less energy potential in them. But you can burn and you can create energy. Now, you can also recycle and you get the plastic value. And then the very best thing to do is just reuse it, and then you have all the value because you don't have to create a bottle at all. You don't have to melt down, you don't have to melt up, you just use it again and again. So